Welcome on the next exercise. The one today will be about gRPC. So I'm gonna start with a quick start because we're not gonna set up a full project today. It would take a little too long and wouldn't be much educative. I hope that's a word. We're just gonna go through the official quick start from the gRPC IO. You can go here from documentation, Java quick start. If you clone this repository, you'll get basically the thing that we'll be working on. And I have it here. So this is the project. We're gonna first follow the steps described here. So we're gonna install the thing, and we're gonna run it. I already did that. So if you're using Windows, make sure that your slashes are in the right order and in the right side. So first we install, then we need to run it. Now if you run it, make sure if you're running Windows that you have forward slashes and not backward slashes and not forward ones, because otherwise you won't be able to run it properly, I guess. Right, so we've started and the server is listening on 50,051. Now we can run the client and greet. Okay, now how do we know that we actually were greeted and it actually went somewhere? Now we can follow the same pattern we did previously and use Wireshark to check it. Now I did already a little filtering so that we would see it without going through all this stuff. But I'm also gonna show you how to set this filter up yourself. It's also described in the manual here in gRPC IO on a blog about Wireshark. So first of all, what you need to do is what you can do actually is set up the proto files, and you can set up the proto files location of the proto files here and edit preference. I have in Polish the Polish interface here, but I suppose it's pretty similar in any other language. So edit preferences, and then if you go to protocols, and so when you go to gRPC, you'll see this thing, some configuration, and then preference for protobuf specified in proto. So we need to go to proto. So let's go to protobuf here. Then you have to set search path. I have set it already to mine path, and this is basically in our case example source main proto. You can't see anything here because this only shows directories. Okay. Now protobuf is encapsulated in HTTP2. So let's see that if we need to set anything up in HTTP2. So we need to set the port, the basic port, and in our case this is this port that server listens to. So I'm gonna set it up already. So this is the port we're gonna listen to, and then we're gonna listen to only gRPC messages. Now Wireshark takes a minute to process, and these are the calls that happened. So in our case we have both source and destination, which are the same, which is not really convenient, I'm afraid. But let's see if we are able to add a port, maybe a port number. Would we be able to do that? Not really. Okay, anyway, we can see it. We can see it here. Here. Where is it? Oh, here. Source is 50,052, and destination is 60. So this is source, this is destination, so we can see what happened. So this is a request, and this is a response. Right, so you can see that source is 59183, and then destination is 551. And then this destination, so we get these all those layers here. So we have IP4, then TCP block, and in TCP it looks like that, which is not very convenient to look at. And then there is HTTP, which is also not that convenient, to be quite honest, in this form. And now we can look at it this way, so in the a little more convenient way. So we have this header authority, header path, hello world greeter, say hello, which is, I believe, much more convenient. We have method, we have scheme, content type, all those other headers. Then we have data. We actually don't have data because we don't have any data in our request. And then we have have this thing decoded as a gRPC message. And now the display. So the fact that we have this HTTP2 and then gRPC inside is configured by what I set up a second earlier. So I'm going to show you how it does look if we don't set it up. And then we have this protobuf message, which is encapsulated here. And this is this message hello world with the name world. That this field has a value of world. So these two fields and value is world string. Okay. Now, if we decided to, you might see a little different view. So if you decide to set your gRPC that, where is it? gRPC here, not to embed it, you'll see it in a slightly different way. So if you do it this way, you're gonna see it as a separate protocol. So you'll have HTTP2 as one layer, and then gRPC as a second layer, and protobuf would be the third one. So gRPC is, and on top of that is protobuf. This might be more convenient to you, so you might prefer this way. Right. So this is the request, and then we also have this response part, which is pretty much the same on top, and then we have our protocol buffer message, which is hello world here. Now you might notice that it's not as readable as XML-RPC, which we investigated previously, which is because protobuf is a binary protocol. You also probably noticed that those are actually text. This text is not, it's pretty readable, right? It's world in normal letters, and that's because strings are sent byte by byte, although they are not, well, this message is not gzipped, so it could be, but it wasn't. So these are just sent in plain text. Protobuf messages can be, well, they are sent by HTTP2, so you can gzip them on a higher level if you want. And even if they were, then we would see it decoded, because Wireshark is awesome. Right. So that's how you can diagnose what happens on your gRPC stream. Now, I did show you gRPC related protobuf. Now, you should be aware that protobuf is not the only protocol that can be used with gRPC. gRPC also supports other protocols. For example, it supports JSON. So an example is here. We won't be going through it, but well, you can take a look. It's there. So basically what you need to do is you need to provide a marshaller that would translate your messages into something that can be sent through the wire. And in this sense, gRPC is protocol agnostic, so you can use it with Avro, you can use it with protobuf, you can use it with JSON, you can use it with XML, you can use it with Cap and Proto, you can use it with Thrift, or with whatever else you want to. We will of course focus on protobuf because it's the default, and it's probably the one that is easiest to grasp out of the box. And it's also the one that you will encounter the most often. So it kind of makes sense to use it. Right. Now that said, let's go back to our Hello World client. What is fairly important here is that our communication happens between a client and a server based on a defined protocol. So both client and server need to know the protocol, and the protocol is defined here in proto files. In our case, we use Hello World Proto. Now this is the protobuf file, and it uses proto-free syntax. Then it has some options which are not that important for us right now. And then there is this important part, which is defining a service. So we define a service greeter, and the service has offers an RPC call, say hello. This say hello takes a hello request as an argument message and returns a hello reply as a response message. Now that's fairly important. Those two are messages, and this is basically a data structure. You can think of it this way. This defines a service that well, you can think of it as a function, so a procedure that is supported by the server, and this defines a message that is sent between server and client. Now this number is a little mysterious, and this is used for forward compatibility. So say in a week you decide that you need also that you only want to greet people above a certain age. So then you add another integer, which is age. And then you decide that age is not enough, but you also need, say, something like, I don't know, social status. And that would be 3. And then after some time you decide that you don't need this age thing anymore. So you can make it optional. That's one option. You can remove it. Now if you remove it, you have to make sure that it actually deserializes, so it's better to remove all the optional things. Now if you have something like that, the server that has this definition, so 1 and fills 1 and 3, will still be able to deserialize something sent with these two versions. And that means that it's kind of a forward compatibility. I mean, it's a pretty good compatibility, to be honest. Now there are some, as you saw already, there are some modifiers. So you can have an optional field, you can have a repeated field, which is basically an array, and you can also have a stream, but the stream is not here. The stream can be here, because gRPC supports streaming requests and it supports streaming responses, which then is basically a two-way communication channel. Right. There are also other types which are not interesting for us right now that much. We can of course have a structure inside a structure, so you can have a hello request, well, hello reply, more of a hello reply here. So you'll have a structure, and that's also okay. The streaming and routing, I think, doesn't provide anything new. Yeah, so as I said, you can have structures here and that's okay. Yeah, and that's the important thing. Now, you might wonder, okay, so we have our proto file, which is fairly simple. We can say it's like 40 lines. Well, actually, 20 lines of code. not that complex, but how does this map to the entire communication thing? So out of this file, the Proto-C compiler generates classes. Now, well, actually it generates sources, so sorry, my bad. It generates sources. Now, into the generated sources. This compiler works a little differently for every language because it's optimized for different use cases. Many languages are supported out of the box. So if you take a look at here, so the official guide supports C#, C++, Dart, Go, Java, Kotlin, Node, Objective-C, PHP, Python, and Ruby. And there are also many others that are supported by the community. So basically for any reasonable language you can have a Proto-C compiler. And well, since they generate source, each one works a little differently. Now the sources are generated into a few places. For our hello world, they're generated in Java and into gRPC. So in our hello world sample, we get hello builders. Builders are fairly simple. This is there is this proto file with some protobuf metadata, descriptor thing, and generated message, field accessor. So basically not interesting. And the main classes for serialization and deserialization, and those are fairly interesting. So they describe how to read the data from a buffer, so from the stream into your data structure, and they are quite complex, you might say. So we had our 20 lines, right? Remember, 20 or 30 lines, and they are mapped into two files for 500 lines each. And that's not all, because we also have this gRPC bundle, and it has another file, and this one has another for 300 lines. And this one is quite important because it describes the interface. So these classes here describe the actual types, the messages that are sent between the data. So hello reply, that it has a message and all this kind of stuff. But then there is also the service, the actual service. And the service is called greeter impl base. So this thing, and as you can see, it has the say hello function, which not accidentally corresponds to this say hello. You might notice that the casing is a little different here, because this one is a Pascal case, and the other one is, and the one in the file is camel case. So that's just to support typical Java conventions. But that's important. And the second thing is these stubs. So we have a future stub and a blocking stub. And the stubs are things that are used by the client. So maybe we can see the actual client now, the client code and the server code. So maybe let's start with the server. So our server here is quite simple. So this is boilerplate, this is boilerplate 2, and also this is boilerplate, and this is boilerplate, and only this thing is important. So basically what happens is on every say hello call, we will reply with hello and name, and then respond and complete. Quite simple, right? And we override this. And if we have our client is even simpler. So this thing is boilerplate, and this thing defines where our server is located, and it is located right now in the local host. And here we create our client, and here is the important thing, which is greet. which is a hello world client, and we do run the greet call. And here we create our request. Here we get our response, which we assigned from the stub. Take a look that we're using a blocking stub. And that's it. So that's the whole interaction. Now, I'm gonna create a few more functions so that you will see how those behave. Say by request returns by reply. And I'm also gonna show you how streaming response is created. We're not gonna dive into streaming, but I'm gonna show you the serialization. Now, one more thing you might wonder, or you know what about about the streaming thing. So if you will be interested about that, you might want to check out the details of those examples. Now, you might wonder, how do we go from this to this? So let's try to do that simple way. So just to run the install again, and maybe it will work, maybe it will work, or maybe it won't. Let's see. It does. Awesome. Now you might wonder, how did that happen, that those files are generated, because I didn't say that yet. So the important thing here is the build Gradle file. So the build Gradle, and that's also, by the way, in this project, the same thing is in Maven and Bazel. I don't know what's the pronunciation for that. I'm gonna use Gradle. So we have this protobuf plugin, and well, there are dependencies to protobuf, obviously, and then the protobuf is configured to use this compiler and generate tasks for everything that is in proto into gRPC, and then the source is in gRPC. So that's the definition. So it's quite simple, but you need to have this protobuf task somewhere so that it runs proto-C on your proto files. And I wanted to have one more thing here, because I wanted to show you an example of a stream response. So we're going to have a stream by request, and then it will return stream of by replies. And I'm just gonna compile that again. And if we take a look at, whoops, it's not here. Oh, of course it's not here, because seymour bias is defined in the greet REPL base. So if you take a closer look at this one, seymour bias, it's not really much different from the other one, right? Except this one only has the response observer and no request, right? So let's see how can we implement that. So let's go to our sources first, and first we're gonna start with overriding public void say say bye. So first we're gonna say bye bye, and just to make sure, we're not gonna go back to Wireshark today because it's pretty exhausting. I mean, it's a very heavyweight tool. It's extremely powerful, but you don't usually want to use it on a daily basis. As long as everything goes more or less fine. So you would rather prefer to stay out of that. So we're just gonna say hello here on the server side so that we know that it actually went through. And here we're gonna say bye. And this is gonna be a bye request, of course. And this is gonna be a bye reply. And here we're gonna have get message. And then we're also gonna say set, of course this is a bye reply. And then we're gonna set age plus 3, which will be, you won't guess it, get age plus 3. And then we're gonna build it. Of course it's a bye reply. And then we're gonna have the third thing, which will be this multi-buy thing. But I don't remember the signature, so I'm just gonna copy it from here. So you can see it's a bit more complex. Where is it? So okay, so let's take a look at this, at what happens here. So what do we actually return? Let's remove the boilerplate a little. So we return a stream observer for byte request, and here we take as an argument stream observer for replies, which sounds a bit weird, right? I mean, you wouldn't expect anything like that, and that's why we're gonna take a look into the hello streaming thing, because I'm gonna show you how to find this thing in the documentation, and not only how to do that. So this is it's in manual flow. If you take a look here, then this is moved into the manual flow, and manual flow control is here. So if we go to our server, and we're going to look for the implementation, it is a bit more complex, because here we have our say hello streaming thing, and it overrides say hello streaming, and this observer is something that we're going to return in a minute. And it has an on a next function, on error function, and on completed function. So it's basically it's a subclass here, and we're gonna have this on next and on error thing. So on the next is something that what we are supposed to return when we get a new request. So what do we do then? And obviously we can do some. We can send something to the server, to the client as a response, or we could just do something on the server. We don't need to do any of those. We're not going to implement that because it's a little too much work for today, and it's also not part of the task. It is part of the extended task if you want to do something a little more complex, and that's pretty awesome to do. But we're not going to cover it here, so I'm going to remove that, and we're just going to live with say hello and say bye, which is the simplest use case you can have. And we're also going to have those two things here. We're going to say have both hello and goodbye. I'm going to move them here, and this is for hello, and for buy, I'm gonna have something similar. So I'm gonna have buy request to have a B request, and then I'm gonna have a B response, which would be a blocking stub, say buy, and this will be a B request, and then this will be of course a buy request, set message, and I'm gonna have a name here too, and then I'm gonna set age to 5, because why not, and then we're gonna have this thing which would be buy request, by response of course, by reply, yeah. So that's kind of convention here. Greeting, buying, B response, get message plus, and here I'm gonna say age, get age plus 3, actually, B response, get age plus 3. Yeah, that's it. So I'm gonna test it. I'm gonna test it right now. So first let's build. Let's hope it will build. It did. Fantastic. Now you might also notice that I didn't implement one of the endpoints, and that's kind of okay for gRPC. So we have pretty much the same. Hello, bye. This one returns hello because I actually also return hello on here. If I change this to buy, it would be buy, but I'm not gonna do it today anymore. Okay, you might also notice that I didn't override the streaming thing, but it is defined in the RPC, so you can do that as long as you don't need an endpoint. You don't have to implement that. Okay, so that's it for today. Good luck.